Hello and welcome to G Fun Facts Online. When you think of the Ice Age, what comes to mind? Probably a world of ice, endless snow, and vast frozen tundras. You'd picture colossal woolly mammoths with their curving tusks, heavily coated woolly rhinos, and maybe even fierce cave lions. It's a landscape defined by brutal, unforgiving cold. Now hold that image in your mind. I want you to add one more animal to that scene. An animal so profoundly out of place, it sounds like a fantasy. Imagine, in the middle of Ice Age Germany, a hippopotamus. Yes, a hippo. The same kind of animal you associate with the warm, lazy rivers of sub-Saharan Africa. Basking not in the African sun, but in the heart of a supposedly frozen Europe. This isn't a mistake. It's a scientific revelation that forces us to rethink everything we thought we knew about this epoch. This is the story of the Ice Age paradox. To solve the mystery of Germany's Ice Age hippos, we first have to break down our simple, monolithic idea of the Ice Age. The period scientists call the Pleistocene epoch, which lasted from about 2.6 million years ago to just under 12,000 years ago, was not one continuous deep freeze. It was actually a dramatic, cyclical series of climatic booms and busts, driven by subtle long-term shifts in Earth's orbit known as Milankovitch cycles. Geologists call these phases glacial periods and interglacial periods. The glacial periods were the ice ages of our popular imagination. During these times, massive continental ice sheets, kilometers thick in places, advanced from the poles, covering huge parts of North America, Europe, and Asia. In Central Europe, glaciations like the Elsterian and Salian were so powerful they completely remodeled the landscape. The first major ice sheet to cover that region arrived as early as 450,000 years ago, grinding down mountains and carving out the valleys we see today. The world cooled, sea levels dropped dramatically as water was locked up in ice, and tundra environments spread across the continents. But then there were the interglacials. These were periods of climatic relief, a planetary exhale. The great ice sheets would melt and retreat, and temperate, sometimes even subtropical, conditions would return to Europe. One of the most famous of these was the Eemian interglacial, which occurred around 126,000 to 115,000 years ago. During the Eemian, it was often warmer than it is today. Hardwood forests of oak and hazel grew far to the north, well into Scandinavia, and sea levels were significantly higher than they are now, flooding low-lying coastal areas. It was during these lush, warm chapters of the Pleistocene that Europe's ecosystem transformed, becoming a welcoming home for a whole host of animals we would today consider completely exotic. And one of the most impressive of these arrivals was an ancient European hippo. Long before the modern hippo made its surprising appearance, Europe was home to an even more formidable species, Hippopotamus antiquus, the great European hippopotamus. This giant of the early and middle Pleistocene first lumbered onto the continent around 2.1 million years ago, having migrated north out of Africa. This was a truly massive animal, considerably larger and perhaps more terrestrial than its living relative. Some individuals are estimated to have weighed up to 200 kilograms, or over 7,000 pounds. That's nearly double the weight of an average modern male hippo. It was a true megafauna heavyweight. Fossils of Hippopotamus antiquus have been found all over the continent, from Spain and Italy to the British Isles, and, crucially for our story, in the gravels of the Rhine River in Germany. This ancient hippo thrived during the warmer interglacial periods. It shared its habitat with other giants of the temperate world. So picture a prehistoric German riverscape during one of these warm spells. But instead of ice, you see lush vegetation. Herds of enormous straight-tusked elephants, known as Paleoloxodon antiquus, animals larger than African elephants today, browse in the open woodlands alongside the narrow-nosed Merck's rhinoceros. And ruling the waterways, you have these colossal hippos. It was a European Serengeti. But the story of Hippopotamus antiquus eventually came to an end. This species disappeared from the fossil record around 400,000 years ago, likely pushed to extinction by a combination of climate change as a new glacial cycle began, and competition from a new arrival. That new arrival was a species that is still with us today, the modern common hippopotamus, Hippopotamus amphibius. For a long time, it was believed that this species followed the same pattern as its predecessor. It was confined to the warm interglacial periods, and it would vanish from Central Europe as soon as the ice returned. For decades, the consensus among paleontologists was clear and logical. Hippos, being animals that need warm temperatures and year-round liquid water, couldn't have survived a glacial period in Central Europe. Their skin is sensitive to cold and requires moisture, and their entire biology is adapted for a warm, aquatic lifestyle. The established timeline said that they disappeared from the region at the end of the last major warm period, the Eemian Interglacial, around 115,000 years ago. It made perfect sense. As the next glacial period, known as the Weisselian, took hold and temperatures plummeted across the continent, these warmth-loving animals would have been forced to retreat south to the Mediterranean or Africa, or they would have simply perished. Any hippo fossils found in places like Germany were automatically assumed to be from the Eemian, or an even earlier warm period. This is where the story takes a remarkable turn. An international team of researchers, part of a project called the Ice Age Window Upper Rhine Graben, decided to take a closer look. The Upper Rhine Graben is a special place. It's a tectonic depression, a rift valley that formed millions of years ago, stretching for about 350 kilometers between modern-day Frankfurt and Basel. This unique geological feature has acted as a kind of continental climate archive, perfectly preserving the remains of plants and animals for millennia in its deep layers of sand and gravel deposited by the river. The team began to re-examine 19 different hippo fossils that had been recovered from this area in southwestern Germany. But instead of just looking at their shape, they used advanced scientific techniques, radiocarbon dating, and ancient DNA analysis. Radiocarbon dating allows scientists to determine the age of organic material by measuring the decay of carbon-14, while ancient DNA analysis can extract genetic code from bone fragments millions of years old. The results were stunning. The bones were not 115,000 years old or older. Instead, the dating showed they were from a period between approximately 47,000 and 31,000 years ago. Let that sink in. This places hippos squarely in the middle of the last glacial period, a time previously thought to be far, far too cold for them to be in Germany. This wasn't just a minor correction to the timeline, it was a bombshell. It meant that hippos had survived in Germany for almost 80,000 years longer than anyone had ever assumed. As Wilfried Rosendahl, one of the lead researchers on the project, put it, the hippopotamus is therefore a true Ice Age inhabitant on the Rhine. So how is this possible? How could an animal synonymous with the hot African savanna survive in a landscape supposedly dominated by ice sheets and tundra? The first question the researchers had was whether this was some kind of unique, cold-adapted species, a quote, woolly hippo perhaps with thicker skin or a different metabolism. The genetic analysis of the fossils provided a clear answer: no. These Ice Age hippos were genetically very closely related to the Hippopotamus amphibius found in Africa today. They were, for all intents and purposes, the same animal, with the same biological needs. The DNA also told another part of the story. The genomic data revealed very low genetic diversity among these German hippos. This is a classic sign of a small, geographically isolated population that has experienced a bottleneck. It seems a small group of hippos got trapped, or chose to stay, in this one particular area and managed to hang on for thousands of years, interbreeding within their limited group. This discovery paints an absolutely extraordinary ecological picture. These hippos, animals that are fundamentally tied to warmth and open water, were living alongside the classic cast of cold-adapted Ice Age megafauna. In the very same fossil layers of the Rhine where the hippo bones were found, Paleontologists have also found the remains of woolly mammoths and woolly rhinoceroses. This is a paradoxical scene straight out of a fantasy novel, an animal that needs liquid water year-round to survive, coexisting with creatures whose bodies were built for sub-zero temperatures and snowy plains. This ecological mix-up is the key to understanding the real nature of the Ice Age. It proves that the climate wasn't a uniform, monolithic deep freeze. Instead, it was a complex mosaic. While vast ice sheets did indeed cover much of the continent, certain regions, like the tectonically sheltered and milder Upper Rhine-Graben, could have served as quote. These were pockets of life, biological havens, that experienced a more temperate microclimate. The valley's lower elevation and sheltered position may have protected it from the worst of the cold. These refugia might have experienced what scientists call interstadials, shorter, less intense warming phases that happen within a major glacial period. These brief warm spells, lasting a few thousand years, could have been enough to allow a species like the hippopotamus to cling on, generation after generation, in their isolated valley, before the cold returned with a vengeance. And there's more evidence to support the idea of a surprisingly mild microclimate in this exact region. Analysis of fossilized wood from the same time period has revealed the presence of large oak trees. We're talking about oaks with trunks 80 centimeters thick, which were growing in the valley until around 40,000 years ago. Just like hippos, stately oak forests are not something you would expect to find in a stereotypical Ice Age landscape. They need relatively temperate conditions to grow to such a size. This reinforces the idea that the Upper Rhine was a unique and temperate haven in a largely frozen world. The revelation that hippos roamed Germany during the depths of the last glacial period does more than just add an exotic new character to the cast of the Ice Age. It fundamentally challenges and enriches our understanding of this entire dynamic period in Earth's history. It is a powerful demonstration that climate and ecosystems were far more variable, complex, and localized than we had previously believed. The simple model of a warm interglacial world and a cold glacial world is too simple. The reality was a patchwork of different environments, where local geography and conditions could create surprising pockets of life. It also speaks to the adaptability and resilience of certain species. While these hippos weren't a distinct cold-adapted species, their ability to survive in a small, isolated pocket for tens of thousands of years in an otherwise hostile continent is a testament to their tenacity. So the image of a hippo surfacing in a bend of the Rhine River, with its breath misting in the cool air, while a herd of shaggy woolly mammoths grazes on the floodplain nearby, is no longer a paleontological fantasy. It is a scientifically supported vignette that highlights the incredible resilience of life and the intricate, often surprising, nature of past climates. The Ice Age was not just a world of ice. It was a world of exceptions, a world of paradoxes, and a world of hidden pockets of warmth, where the African river horse made its last, improbable stand in a frozen Germany. The fossils from the Rhine continue to be a valuable window into this complex and fascinating prehistoric world, proving that even in the deepest freeze, life, in the most unexpected of ways, finds a way. Thanks for tuning in to Fun Facts Online.